Welcome to Academy, the place for mathematics and science. Dear students, in the last class, we were discussing the chapter real numbers. Now, let's go for continuing this. You all know that yesterday we conducted the weekly test on the chapter real numbers. Many students have attempted, and even many of you have attempted very well also. I went through your answer sheet. I came to know that your effort is very good. Please continue the same. And some students who have not got the answer for a particular question, I have already sent you the key answers. Please use the key answers and once you go for working out. Okay, now let's continue the chapter real numbers. You all know that day before yesterday, we were solving the problems in the exercise number 1.1, right? In that, the first four were over and it was related to finding the HCF by Euclid's division algorithm. Second type was writing the given term, expressing the even number or odd number in the particular form. It may be 4q plus 1 and 4q plus 3, or 6q plus 1, 6q plus 3, 6q plus 5. Similarly, another very important statement was there, that is, square of any positive integer can be written in the form of either 3m or 3m plus 1. Now, I am going to take the same type of problem, but this time, in the fifth one, we are going to focus on expressing the cube of the number in the particular form. It is 9m, 9m plus 1, 9m plus 8. Yes, please go for copying with me. Right. In exercise number 1.1, continue this and question number 5. And please put star mark for this. Put 3 star mark because it was also given in the examination. The statement is like this. Use Euclid's division lemma. Use Euclid's division lemma to show that the cube of any positive integer, is of the form 9m or 9m plus 1 or 9m plus 8. This is the statement for some integer m. 9m plus 8. Okay. As we have already come to know how to express even or odd squares of the number in particular form, let us follow the same steps. Right. Prove. We do not know what is that positive integer. Now first let's go for assuming the positive integer. Let it be a, right? Let a be a positive integer. Positive integer. If you consider b, then if a is greater than b, like this, and a is greater than b, then by Euclid's division lemma or algorithm, it can be written as a equal to b cube plus r, where 0 is less than or equal to r less than b. Now call it as statement 1. And observe it. Here we are going to express the cube of any positive integer is of the form 9m plus 1 or 9m plus 8. In the previous statements, we have come across 2q, then 4q plus 1, 4q plus 3, like that. The divisors were 2 and 4, even 6 also. And we used to substitute those numbers in place of divisor B. But here 9m is there. Can we go for taking 9 in place of B? Of course we can take. If it is so, then what will be the possible remainders? Means if 9 is the divisor, the possible remainders will be 0 to 8. If r equal to 0, r equal to 1 and up to 8, it takes a lot of time. So to save the time, the best thing what we can go for is, let's go for taking 3 in place of B. The reason is 9 is the multiple of 3, and when you go for finding the cube of 3, it will be 27. 27 is the multiple of 9. Hence, cube of number can be expressed in these form. Hope that you all have understood. Right. Substitute B equal to 3 in 1. Instead 9, we are taking 3 because 3 cube is 27. 27 is the multiple of 9. Now, statement 1 can be written as A equal to 3 cube plus R. Then the possible remainders will be 0, 1 and 2. Substitute one by one. First, if R equal to 0, then write A equal to 3 cube plus 0. 3 cube plus 0 is nothing but just 3 cube. Go through the statement. Cube of any positive integers. Then what should be in the next step? Yes, it is. We should do cubing on either sides. Right. Cubing on both sides. Then we can write it as A cube or A whole cube. That's equal to 3 cube whole cube. Then apply cube to both the terms. 3 cube is 3 cube. 3 cube is 3 into 3 into 3. Multiply this. 3 3s are 9. 9 3s are 27. And cube whole raised to the power 3. 27 cube. We are going to prove that the cube of any positive integer will be in the form of either 9m plus 1 or 9m plus 8. Hence, I'll write it as a multiple of 9. 27 can be written as 9 3s are 9 into 3 into q raised to the power 3. Now this is equal to, see that here is 9, I'll write it as it is. In place of 3 q raised to the power 3, I'll write m. Now we can write where m is equal to 3q. And you may call it as statement A, B, C or alpha, beta. Then even if you go for taking the number, write it as 2. Next, similarly, if r equal to 1, you just go for highlighting this. Right. If r equal to 1, then A is equal to 3q plus 1. 3q plus 1. Here also go for cubing on either sides. This is A whole cube and this is 3q plus 1 whole cube. Now observe the RHS part. RHS part, that is 3q plus 1 whole raised to the power 3 is in the form of an identity, that is A plus B whole cube. Just go for recalling that identity. A plus B whole cube can be written as, it is A cube plus B cube plus 3 A square B plus 3 A B square, right? Even this can also be written as A cube plus B cube 3AB into A plus. For this statement, Let's go for following this pattern. Please go on writing with me. 3 cube plus 1 whole cube. It is a cube. A is 3 cube. In place of b, 1 is there. Right. 1 whole cube plus 3a square b. 3 into 3 cube whole square into b is 1 plus 3ab square. 3 into a is 3 cube, b square. B is 1 whole square. Now simplify it. 3 cube whole cube. Apply cube to both. 3 cube. 3 cube is 27. Q raised to the power 3 plus 1 whole cube is 1. Next, first apply square to 3. 3 square is 9 and multiply this with other numbers. 3 square is 9. 9 3s are 27. 27 ones are 27. And q whole raised to the power 2 can be written as q square. Plus, here also, first multiply the numbers. 1 square is 1. 1 3s are 3. 3 3s are 9. Then write q as it can be rewritten as 27 q cube plus 27 q square plus 9q plus 1. I have written in the standard form. Now, observe the first 3 terms. You can come to know that there is a common factor. What is the common factor? No doubt it is 9 cube. But as we are going to express the number in the form 9m, 9m plus 1 or 9m plus 8, just I'll go for taking only 9 as the common factor. Right? 9 into 9. How much are 27? It is 3 is up. Q cube as it is 9. Again 3 is up. Q square as it is plus 9 ones are q as it is. But 1 is not the multiple of 9. I'll write it separately. That is 1 as it is. Next, here I'll run this part. Now, it can be continued as 9 in place of 3q cube plus 3q square plus q. I'll write m. 9m plus 1 as it is. Where m is, write this. 3q raised to the power 3 plus 3q square plus q. You may call this as statement 3. Next, we have one more possibility. Let's go for taking that also. First, r equal to 0 was over, r equal to 1 was also over. Now, we are going to take if r equal to 2, right? If r is equal to 2, then how do you write? A is equal to 3q plus 2, right? In place of remainder, we have taken 2. Go for cubing on either side. A whole cube is equal to 3q plus 2 whole cube. Observe the RHS. Again, it is in the form of a plus b whole cube, right? Expand it. It is a cube plus b cube plus 3a square b plus 3ab square. So substitute 3q in place of a and 2 in place of b. It's very simple. for substitution. 3q, 2. Here 3q, 2. Here also 3q, then 2. Now simplify. It is equal to 3 cube whole cube. 3 cube is 27. Q raised to the power 3 plus 2 cube is 8 plus. Now apply square to 3. 3 square is 9. 9 3s are 27. 27 2s are, it is 54. Apply square to cube. It will be q square. Once I repeat, 3 square is 9. 3 square is 9. 9 3s are 27. 27 2s are 50. Then q square. Plus, here, apply square to 2. 2 square is 4. 4 3s are 12. 12 3s are 36. And q as it is. Hope that you all have understood. Now, just go for writing this in standard form. As 27 q raised to the power 3 plus 54 q raised to the power 2 plus 36 q plus 8. Here also we can come to know that in the first 3 terms, the coefficients 27, 54 and 36, they are all multiples of 9. Hence you can go for taking 9 as common factor. 9 into 9, how much is 27? It is 3 is q raised to the power 3 plus 9, how much is 54? Yes, 9 6 are 54. 9, how much is 36? Yes, you are right. It is 4 Now plus 8 as it is, because it is not the multiple of 9. Now this can be written as 9. I'll take the terms inside the brackets as m, 9m plus remaining 8. See that? Where m is 3q raised to the power 3 plus 6q square plus 4q. Hope that you have all have understood. Now write AQ. Highlight that and call it as statement 4. 3 and 4. Now observe statement 2, 3 and 4. 2 is a cube is 9m. Next statement 3, a cube is 9m plus 1. Then a cube is 9m plus 8. So the cube of any positive integer is of the form either 9m or 9m plus 1 or 9m plus 8. Clear? Yes, right. From the statement 2, 3 and 4, we can conclude that write that statement. That is, the cube of any positive integer is of the form. The cube of any positive integer is of the form 9m plus 1 or 9m plus 8. So you have to continue this conclusion. Copy that complete. Now I'm going to rub it. Yes. If your writing is completed, take scale and pencil, draw a line with pencil. I've already told you, after solving each and every problem, you have to draw a line with scale and pencil. Then your notes look good. Dear students, even I told you that soon after completing this exercise number 1.1, we will focus on one of the important riddle which has been given in the second page of this chapter. It is related to an idler and an exceller. Hope that you might have read that statement. Now we are going to solve that. And this riddle is related to Euclid's division algorithm. Let's go for that. Now, you just continue the number. Fifth one was over. Now it is sixth one. It is again the statement will be taken from the textbook. Page number 2. It is a bit lengthy statement. Please go on writing. Sixth one. And with respect to that, we have the statement like this. A trader was moving along the road selling eggs. Right. I put 3 star mark for this also, because it was also given in the examination. A trader was moving along the road, selling eggs. An idler who did not have much work to do. An idler who did not have much work to do. Don't be lagging. Please go on writing with me. To do. Started to get the trader into what did you? Started to get the trader into a wordy duel. This grew into a fight. The situation is very nice. This grew into fight. It doesn't mean that you should go for it doesn't mean that you should enjoy their fighting, but there is a statement. It is the problem. We know that in the society it is common. The people who are not having the work to do, obviously they'll go for giving trouble for others. Here also the same thing is there. This grew into a fight. Come on. He pulled the basket with eggs. He pulled the basket with eggs. This is that baskets, some eggs were there, and dashed into the floor. Sorry, and dashed it on the floor. Full stop. The eggs broke. Obviously, the eggs broke. Full stop. The trader requested the panchayat. The trader requested panchayat to ask the idler to pay for the broken eggs. To ask the idler to pay for to pay for broken eggs. Broken eggs. Full stop. The panchayat asked the trader. The panchayat asked the trader. The panchayat asked the trader how many eggs were broken. Trader, how many eggs were broken? Full stop. He gave the following response. The following response. His response is really very nice. As I said, this statement is related to Euclid's division algorithm. He has also given the response in the same way. You'll come to know that. Continue the question. The trader will tell that if counted in pairs, that means if you go on counting 2, then at last we will get 1. So right, if counted in pairs, 1 will remain. 1 will remain. Next, if counted in threes, that is, if you go on counting 3x, then at last we will get 2. This is the response given by the trader. 2 will remain. 2 will remain. Next, if counted in 4s, then how many will remain? Yes, you are right, it is 3 will remain. 3 will remain. Next, if counted in 5s, then 4 will remain. 4 will remain. If counted in 6s, if you go on counting 6 eggs, at last we will get 5. 5 will remain. 5 will remain. And one more, the last response was, if counted in 7s, nothing will remain. Nothing will remain. Next, one more condition is there. The condition is, he tells that my basket cannot accommodate more than 150 eggs. Means the maximum number of eggs that can be placed in the basket is 150. Right. My basket cannot accommodate more than 150 eggs. So with this information, then how many eggs were there in the basket? That should be calculated. Right. How many eggs were there in the basket? How many eggs were there in the basket? Though the statement is too lengthy, it is very interesting and also easy to understand. Not only that, even for solving also, it is easy. Now let me go for explaining this. Hope that you have completed writing this statement. Now, let's move on to this. Go through the statement. The statement is like this. There is a trader, means is a person who is going to sell the eggs. He is an egg seller. And other person who is not having the work, he will give trouble to the trader. Then they afterwards they started fighting, and the person who did not have the work, nothing but idler, he pushed him, and even he pushed the basket of eggs also. Hence, eggs they fell down, and some eggs were broken. Then obviously the trader, he went to Panchayat. Then there he asked the justification for that, and the Panchayat asked the trader how many eggs were there in that basket, and these are the responses given by the trader. Go through this response once. If you go on counting 2, at last 1 will remain. Go on counting 3, then 2 will remain. Similarly, 4s, 3 will remain. 5s, 4 will remain. 6s, 5 will remain. 7s, if you go on counting 7 and 7 and 7, then nothing will remain. Hope that you have understood. Just by observing the last statement, what you will come to know? If you go on counting 7, nothing will remain, which means that the number of eggs in the basket it is the multiple of 7. Because you'll go for counting 7, 7, then 7, 7, 7. Last 0 means it is the multiple of 7. And one more condition is that the trader's basket cannot accommodate more than 150 eggs. Maximum number of eggs that can be placed in his basket, it is 150. Then how many eggs were there? Let's go for finding them. Here I have this. The number of eggs in the basket, we do not know that. Let's go for assuming that as either X or A, B, whatever the letter you want, you may take. Here, let's go for taking X. Right. Write data. Let the number of eggs in the basket be A. Next. Then what is the capacity of the basket? It is 150. Capacity of the basket is, just put equal to 150 X. And you are going to find out the total number of eggs in the basket, that is A. Let's go for calculation. Before going to that, just once we shall recall the statement, that is Euclid's division algorithm. We used to write the statement like this: A equal to B cube plus R. R is the remainder. A equal to observe. Here B is the divisor, Q is quotient, and R is the remainder. Just go through any one of these these responses given by the trader. If counted in pairs, if you go on counting 2, nothing but the multiples of 2, at last 1 will remain. What does 1 indicate? Very good. It is the remainder. Just here the point. R equal to 1. So please don't go for writing. Observe this carefully. Plus. Here. If you go on counting 2s, here the divisor will be 2. But what about the quotient? Quotient we do not know. You may go for taking any letter. Understood? Yes. Similarly, if you go for taking m, it will be 2m plus 1. If you go on counting 3s, you may take this as 3n. 2 will remain. That can be written in this way. Did you understand? Okay. Now, here I'll write. If we are taking, let the number of x in the basket be a. As I said, you may take x also, y also, whatever the letter you want. Here I'll write. By Euclid's division algorithm, from the statement, by Euclid's division algorithm and from the given statement, that is, if counted in pairs, 1 will remain. That can be written like this. If counted, please write with me, counted in 2s, 1 will remain. 1 will remain. This can be written as, say, the number of x is a and the number of x, the response regarding the number of x given by trader was counted in 2s. It is 2b plus 1 will remain. Plus 1. A equal to 2b plus 1. Similarly, if counted in 3s, they are given 2 will remain. 2 will remain. It can be total number of x is a. This can be written as, that is, it is to be counted in 3s. When it is counted in 3s, 2 will remain. We can write it as 3c plus 2. Next, the third response was, if counted in 4s, 3 will remain. If counted in 4s, 3 will remain. 3 will remain. Then total number of x is a. And this can be written as multiple of 4. That is 4. I have taken here c. Then I'll take d. Plus remainder will be 3. Next, another response is, if counted in 5s, 4 will remain. Right. If counted in 5s, if counted in 5s, 4 will remain. And this can be written as a is equal to 5. Here d is there. I'll go for taking e plus 4. Next, if counted in 6s, right? If counted in 6s, then 5 will remain. 5 will remain. This can be written as a equal to 6f plus 5. And the last response is, if counted in 7s, if counted in 7s, how much will remain? Nothing. That is 0 will remain. Nothing will remain. And this can be written as a equal to 7g plus 0. I call this statement as 2, right? And this as 3, this as 4, this as 5, this as 6, and this is 7. Hope that you all have understood. And even some of you may be thinking that why we have taken B, C, D, E, F, and G. We do not know the how many multiples of 2, 3, 4 plus remainder will give the total number of x. Hence, as these multiples are different, hence I have taken B, C, D, E, F, G. Next, observe the last statement, that is A equal to 7G plus 0. Nothing but if counted in sevens, nothing will remain. As I said, if remainder is 0, the number is completely divided by the divisor. Then the number will be the multiple of the divisor. So here from statement 7, can we say that the number of x in the basket was the multiple of 7? Yes, right. It is. From statement 7, we can say that the number of x in the basket, the number of x in the basket is the multiple of 7 is the multiple of 7. I'm just highlighting multiple of 7. Then you are very familiar with multiples of 7, right? Nothing but table 7. And please do remember the maximum number of x that can be placed in the basket is 150. That multiples of 7 should be statement number. What is that number? Observe. These statement numbers. Statement 1 was not written. Okay, let it be 2, 3, 4 only. Let's write. The multiples of 7 should be less than 150. Go on writing with me. Multiples of 7 less than 150 are, what are these? It is 7, 14, 7 3s are 21, then 28, 35, 42, 49, 56, 63, 70, then 77, 84, next is 91, next 98, next 105, 119, 120, 105, 112, 119, next plus 7, 126. I'll continue to write it. 126. Then 133, 140, next 147. I cannot take more than this. This is the last multiple of 7 less than 150. So these are the possible numbers which represents the total number of x were there in the basket. But we do not know what is that number. Then how do you go for identifying that number? Yes, the number, there is a number among these numbers, there is a number which satisfies these statements 2, 3, 4, 5, 6, and 7. Now we are going to identify that number. Okay, it is to be done by trial and error method only. Observe, go through the statements. If counted in twos, this is the first statement. By mistake, we have written it as 2. Let it be. If counted in twos, 1 will remain. If you go on counting 2, 1 will remain. That means the number of whether the number is even or odd. See that it is in the form of 2q plus 1. Even or odd? Yes, anybody can respond. It is odd. So among these numbers, very good. Among these numbers, there is an odd number which represents the given condition. Hence, we should neglect all the even numbers. See that? Just encircling even numbers. We are not going to take these. 56, 70, 84, 98, 112, 126, then 140. Don't go for taking these. Then remaining numbers are there. Among the remaining numbers like 721 up to 147, there is a number which represents the total number of x. Okay. Here a equal to 3c plus 2 is there. Means if you go on counting 3's, 2 will remain. If you go for taking the multiples of 3, 2 will remain. Which means that from this statement we can conclude that the number is not the multiple of 3. Hence, I go for removing the numbers which are the multiples of 3. See, 21. Next, 63 won't come. Then multiple of 3. 105 is the multiple of 3. Next, 133, 147 is the multiple of 3. Next, if you go on counting 4, 3 will remain. Firstly, it is not an even number. We have removed all the all even numbers. Next, if you go on counting 5's, 4 will remain, which means that it is not the multiple of 5. So let's go for removing the multiples of 5. It is 35. Then other than that, yes, only that is. Next, remaining numbers are there. Just for your reference, here I am writing the remaining numbers. They are, one is 7, second one is 49, third one is 77, next 91, next 190, another one is 133. So among these 6 numbers, one will represent or one will satisfy all these conditions. We have to identify that number. See that if you go on counting 2's, 1 will remain. If you go on dividing this 7 by 2, obviously 1 will remain. But check whether 7 satisfies second condition. If you go on counting 3's, 2 will remain. Divide 7 by 3. On dividing 7 by 3, 3 2's are 6. 1 will remain. But actually 2 should come, right? Hence 7 won't come. Next, 49. See, just check that. Obviously, it is all these are odd numbers. If you go on counting 2's, 1 will remain. If you go on counting 3's, 2 should remain. 49. Divide by 3. 3 1's are 3, 1. Then carry down 9, 19, 3 6 are 18, 1 will remain. But actually, 2 should come. Hence, 49 won't come. 77. 77 satisfies this condition. Second condition. Third condition. See that 3 2's are 6. 1 will remain. 17, 3 5's are 15. 2 will remain. Of course, it satisfies the third statement. Let us check fourth statement. If you go on counting by 4, 3 should remain. See, divide this by 4. 4 ones are 4, 3 will remain, carry down 7. 4 nines are 36, 1 will remain, but actually 3 should come. So this does not satisfy. So remaining 3 numbers are there. 91. Of course, it satisfies second condition. Third condition, if you go on counting, 3s, 2 should remain. Divide 91 by 3. 3 30s are 90. 1 will remain, but actually 2 should come. Hence 91 will also not come. It's 190 and 133. See, 190, it satisfies the second condition because it is odd. If you go on counting 3, divide this by 3. 3, 3s are 9, 2 will remain. It is 29. 3 9s are 27, 2 will remain. So it satisfies third condition. Fourth condition, if it is, if you go on counting 4, 3 should remain. That is, divide 119 by 4. 4 2s are 8. 3 will remain 39. 4 9s are 36. So 3 will remain. It satisfies fourth condition. Next, if you go on counting 5s, 4 should remain. See that 115 is the multiple of 5. 4 will remain. Satisfies fifth condition. Next, if you go on counting 6s, 5 should remain. Divide this by 6. 6 1s are 6. 5 will remain 59. Then 6 9s are 54. Then 5 will remain. It satisfies even sixth statement also. Then seventh statement. Obviously, it is the multiple of 7. It will also satisfy seventh statement. Hence, can we say that this is the number which satisfies all the conditions, and we can take this as the total number of eggs in the basket? But you all may be thinking that what about 133? Let us check it out. 133. Obviously, it is odd number. It satisfies second condition. Third one, if you divide this by 3, 2 should be the remainder. Now 3 4s are 12. 1 will remain 30. 3 4s are 12. 1 will remain. But 2 should remain. 133 will also not come. Hence, we can say that 119 is the total number of eggs in the basket. So, because of explanation, it has taken a bit more time. But if you go for solving yourself, it takes, no doubt, it saves your time also with your fast calculation. Here I'll write by trial and error. Trial and by trial and error method, 119 satisfies the statements 2, 3, 4, 5, 6, and 7. Therefore, the number of eggs in the basket, therefore, the number of eggs in the basket is 190. 190. Hope that you have understood this. Now, the exercise number 1.1 has been completed. Next, we are moving to another concept. Just before going to that, once you recall fundamental theorem of arithmetic, go through that statement. Fundamental theorem of arithmetic. I'll rub this completely. This type problem was given in the previous year exams for 4 marks. So please do practice, don't neglect this. But some numbers were changed. So recall fundamental theorem of arithmetic.
If you wanted to ask questions, you can show the raise hand symbol. So I will send you the unmute symbol.
Yes, students. Now let's move on to solve the problems on the next concept, that is on fundamental theorem of arithmetic. Write the side heading, the fundamental theorem of arithmetic. The fundamental theorem of arithmetic. Dear students, in the very second period only, we have already come across the statement of fundamental theorem of arithmetic. It is one of the property of a positive integer. Just to recall the statement of FTA, according to this, every composite number can be expressed as the product of the prime factors, right? And this prime factorization is unique apart from the order in which the prime factors occur. If I go for taking a simple example like 20, please don't write, just observe. Let's go for finding its prime factorization. Prime factorization means the method of expressing the given number as the product of its prime factors only. Hence, let us find out the prime factors. As it is even number, it can be divided by a prime number called 2. 2 tens up. Then 10, again it is even number, start dividing this by 2. 2 5s up. Then 5 itself is a prime number. Now 20 can be written as 2 into 2 into 5. This can also be written as 2 square into 5 because 2 is repeated by 2 times. So this is the prime factorization of 20. And this method is called division method. In your previous classes, that is even 6th and 7th, you have learned how to find out the prime factorization of the given number by factor tree method. Is it not? Just we shall go for recalling that also. Here, we are going to find out the prime factorization of 20 by factor tree method. Observe, I am going to make the branches. 20, it can be divided by 2. Same one. 2 how much are 20? It is 10s up. Then 10 is not a prime number. Again, it can be made as branch. Then again, as it is even number, then this is 2 5s up. Observe it. To write the prime factorization, we will go for taking these factors. From here, 2 into 2 into 5. Nothing but 2 square into 5. Please don't neglect, even such a simple statement were also asked in the examination. The statement was like this. Write the prime factorization of the number like 143, 120, 60, like this. And with respect to this, will they ask the factor tree method? No, they won't give you the particular word factor tree. Instead, what they can give is like this. What is the missing term in the factor tree or in the prime factorization of 20? Just observe it. It's very simple. Here, 2 5s are 10. This is the way they may go for asking the question. Even they have asked also. Now, let's go for solving some problems on fundamental theorem of arithmetic. Right. What examples? Write with me. What examples? First one. First one, right. Find the prime factorization of the following numbers. The following numbers in two different ways. In two different ways. First one, take that one only, 20. Just go for finding. Just keep writing that down. Find the prime factorization of 20. I've taken very simple number, 20 in two different ways. Here are mine. First one, it is 20, that is by division method. It can be written as 2 tens, then 2 5s. Right. 20 is equal to 2 into 2 into 5 is nothing but 2 square into 5. This is the prime factorization. And another way, as I said, factor tree method. That is 20, make the branches, they are the factors. 2 tens up 20, then make the branch of 10. That is 2 5s up. Again, you may write therefore 20 as 2 into 5 is written as 2 square into 5. Now, let me go for 20. Another one. Second one. It is 72. Yes. 72. I can just go for finding it by both the methods. First method, by division. 72. As it is even number, you can start dividing this by 2. 2. 3s are 6. 1 will remain 12. 3, 6 are. And as it is simple number, you can take 2 36 are 70. 36. Even number, it is 2 18s. 18 is even number, 2 9s. 9 is the multiple of 3. You can write 3 3s. Now you can write this as 72 as, okay, 2 is how many times? 3 times. And 3 is 2 times. Hence it can be written as 2 cube into 3 square. Right. Similarly, by factor tree method, 72 from this number, start making the branches. 2, it is 36 up. Next, make the branch of 36. 2, it is 18 up. Then 18 is there. 2 9s up. Then 9 is, it is 3 3s up. Conclusion. Therefore, 72 is equal to 2 cube into 3 square. 2 cube into 3 square. Over. Yes. Now I'll go for taking another one which was given in the examination. I'll rub this. And first one, let it be as it is. Third one, actually, they have given the factor 3 only, but it should be continued. And in the first, I'll take that number which has been given in the textbook only. This is 32,760, and it has been given like this. Here, this is 2. Don't go for solving. First, just listen to me. I'll give you an information. That information is in the examination. Some student are asking. A student is asking that, sir, give some time for writing. So whenever you want, whenever you have to write, I'm telling that please do follow my instruction. Then it will be easier for copying. Okay. Now the question was given like this. Find the prime factorization of 32,760 by continuing the factor 3. It was given this much only. Now it should be continued. 32,760. Please start writing it. As it is even number, it can be divided by 2. They only have given 2. Now let us continue this. This is 2. 1s are 2. 1 will remain. It becomes 12. 2 6 are 12. Then 7 is there. 2 3s are 6. 1 will remain. It is 16. 2 8s are 16. Then 0 as it is 16,380. Next, again it is even number. It can be divided by 2. Right. Make 2 branches. The first one, it is 2. Second one. Right. 2 8s are 16. 3 is there. 2 1s are 2. 1 will remain 18. 2 9s are 18. Then 0. Got it? Again, this is even number. Start dividing this by 2. Make branch. It is 2. 4s are 8. 1 is there which is not divisible by 2. Then 0s are. See, 2 40s are 18. 1 will remain. It becomes 19. 2 9s are 18. 1 will remain. It is 10. 2 5s are. Next, observe this number ends with 5. Therefore, it can be divided by 5. Make branch. This is 5. Yes, 5. 5 8s are 40. 9 is there. 5 1s are 5. 4 will remain 45. 5 9s are 40. Observe this number. 8 19. 8 19. If you go for using the recalling the divisibility rule, you can say that from which number it can be divided. Yes, it is divided by, or it is divisible by 3, because just add the digits. 8 plus 1 9, 9 plus 9 18. 18 is the multiple of 3. Very good. You can start dividing this by 3. Now it is right. 3 2s are 6. 2 will remain 21. 3 7s are 21. Then 3 3s. Once you check that 3 2s are 6, 2 will remain 21. 3 7s are 21. Then 3 3s are 9. 273 is there. From which number it can be divided? Very good. Again, it is by 3 because the sum of the digits 2 plus 7 plus 3 it is 12 is the multiple of 3. Very good. Yes, it is 3. 3 9s are 27. Then 1s are 91 is there. From which number it can be divided? Very good. Correct. From which number it can be divided? Good, good. Not from 3. 91. Is it the multiple of 3? No. Yes, very good. It is by 7. 7. How much? 7. 7 1s are 7. 2 will remain. Then it becomes 21. 7 3s are. If you know the table 13, directly you can write 13 7s are. Even 7 13s are. Both are same one. Now, please write the prime factorization of this number. It is important one. It was given in the examination. Put 3 star mark for this. And right. So here I don't have space, so that I'm writing here 32,760 can be written as 2. How many times? It is 3 times. You can write. It is 2 cube. 2 cube into here 3 2 times 3 square into 5 into 7 into 30. Doesn't look good. Here I'll write 32,760 can be written as 2 cube into 3 square into 5 into 7 into 30. This is the prime factorization of the given number. Prime factorization of given number. And we won't expect the order. See here, actually, I have written in the order 2, 3, 5, 7, 30. Whatever the order it may be. Even you may shuffle the factors also. Hope that you have copied. Division method, you may do that yourself. I told you, I have already taught you how to find out the prime factorization of given number by division and factor tree method in first 2 problems. And this was taken from the NCERT textbook, and also it was taken from your previous year question paper. Now I'll go for rubbing this part. We are moving to the next type. Before going to the next type, I'll remain these 2 as it is. That is the prime factorization of 20 as well as the prime factorization of 32,760. Observe both the numbers, that is 20 and 32,760. What is the common observation that we can make in these 2? No doubt, both are even numbers. Both are divisible by 2. Other than that, yes, both the numbers end with 0. Both are divisible by 5 also. Of course, both are divisible by 10. But apart from this, you can notice that in the given number only, you can notice that both the numbers end with 0. Now, even you should observe their prime factorization. Prime factorization of 20 is 2 square into 5. Then 32,760, we have already written, it is 2 cube into 3 square into 5 into 7 into 13. You can, both are composite numbers, they are expressed as the product of their prime factors. So then you can say that it is according to the prime factorization, nothing but fundamental theorem of arithmetic. My simple question is, in both, you can observe the uniqueness of the fundamental theorem of arithmetic. What is that? Uniqueness of fundamental theorem of arithmetic. Yes. That is the prime factorization of both the numbers having the prime factorization which contain both 2 and 5. Just observe it here also 2 and 5. So from this we can conclude that any number whose prime factorization consists of both 2 and 5, that number ends with 0. Clear? This is the uniqueness of fundamental theorem of arithmetic with respect to the number which ends with the digit 0, not power 2 raised to the power n into 5 raised to the power n. It will come at last, I'll tell you that. And giving you the information regarding the number which ends with 0. Any number which I'm not at all teaching you about terminating, non-terminating or non-terminating recurring. Just come to this concept only. Just we are in the prime factorization. Any number which ends with 0 has the prime factorization which contains both 2 and 5 as its factor. So based on that, let's go for solving the problem. This is second one. Right. Second one. I'll take from the textbook one. Right. Check whether 4 raised to the power n ends with 0. For any value of n, and n is a natural number. Hope that you have copied. Now observe this carefully. Don't go for writing. Just I'll give you time for writing. First you understand the statement and my explanation. You are going to check whether 4 raised to the power n ends with 0. Here the given number is 4 raised to the power n. In that the base is 4. I'll go for finding the factorization of 4. You can write it directly. Here 2 2s are 4. 4 can be written as 2 square. Does it obey the uniqueness of fundamental theorem of arithmetic? Does it, will it satisfy? Yes. Will it satisfy the fundamental theorem of arithmetic? Uniqueness of fundamental theorem of arithmetic? No. Why? Yes. The reason is it doesn't have the factor 5. Got it? Because only the prime factorization of 4 consists of only 2. There is no 5. There is no factor 5. Hence, it does not satisfy FTA. If it does not satisfy FTA, you can say that it does not end with 0. Clear? Right. Now, you may please go for writing as we are going to check. Right. Verification. Don't write solution or answer. You have to write verification. Right. 4. 2 2s are. Then 4 equal to 2 square. Here you should write the prime factorization. Prime factorization of 4 does not contain the factor 5. Does not contain 5 by the uniqueness of fundamental theorem of arithmetic. You can say that 4 raised to the power n does not end with 0. End with 0. Over. Next. Third, another one, simple one. Right. Check whether 125 4 raised to the power n ends with 0. They will give only this much answer. Ends with 0, where n is natural number. Just go for writing yourself. Check whether 125 raised to the power n ends with 0. What do you say? Does it end with 0 or not? Yes, you're right. Does it end with 0? No, correct. No is the right answer. Let us come to know how is this? Right, verification. If it is already written, just cross check. If not, right way. It is 125. First, find out the prime factorization of this. It is divisible by 5. 5 2s are 5s are. Then 5 5s are. Here 125 can be written as 5 cube. Observe the prime factorization of 125. It consists of only 5. There is no 2 at all. We know that any number whose factorization consists of both 2 and 5, then it ends with 0. So here it does not contain 2. Hence, it does not end with 0. Right. The prime factorization of 125 does not contain 5 by the uniqueness of fundamental theorem of arithmetic. 125 whole raised to the power n does not end with 0. So does not contain 2. Does not contain 2. By the uniqueness of FTA, it does not end with 0. Then you all may be thinking that, sir, is there any number which ends with 0 to which satisfies the uniqueness of FTA? Yes, of course, many are there. 20, 30, 40, 140, so many are there. But in the examination point of view, these will be given in different ways. Now, let me give you one such problem. Even it was given in the examination as well. Now, I'm going to give you the same Please copy and put 3 star mark. Right. It is fourth one. Fourth one, put 3 star mark. Right. Check whether 36 into 25 whole raised to the power n ends with 0. Then what do you say? Does it end with 0? Don't say just by multiplying those two. My question is very simple. Whether it ends with 0 or not. You have to say yes or no. Yes, very good, very good. 2, 3, 4, 5, 6. Many students. Yes, many students are telling that. Yes, it ends with 0. But how is this? We have to check that. We have to verify it by using fundamental theorem of arithmetic. Enough, enough. Now continue with. Right, verification. Here we have two numbers. One is 36 and another one is 25. Here are right. Find out the prime factorization of both 36. 2 18s are then 18. 2 9s are 9. 3 3s are. And 36 can be written as it is 2 square into 3 square. Just beside that only, right? The prime factorization of 25. It is 5 5s are. Now we can write 25 as 5 square over. But the given number is right now. It is 36 into 25. Even you can take whole raised to the power n. 36, it can be written as 2 square into 3 square into, whereas 25 is 5 square. Whole raised to the power n. Observe the prime factorization of the given number. This is the given number. Yes, you are right. Very good. This prime factorization of the given number consists of both 2 and 5 as their factors. Hence, we can say that it ends with 0. Right. The prime factorization of 36 into 25 consists of both 2 and 5. Both 2 and 5 by the uniqueness of fundamental theorem of arithmetic. By the uniqueness of fundamental theorem of arithmetic, we can say that 36 into 25 whole raised to the power n ends with 0. Ends with 0. Even by just a general method also you can verify this. Just if you go for multiplying 36 into 25, you will get a number that ends with 0. Just look here, 36 into 25. 25 6 are 150. 0, 15 is the carry. 25 3 is 75 plus 15, 90, 900. See the number ends with 0. Here, hope that you have understood. And regarding again the fundamental theorem of arithmetic, we have another very important concept, that is about the highest number from which the given numbers can be divided. Could you tell what is that? the highest number from which the given numbers can be divided. Very good. It is HCF. Another concept already one student has given. Another one is LCM. That is the least common multiple or lowest common multiples. These two are very important concept. 100% one question will be there on HCF and LCM. So while coming to the tomorrow,
Sir, unmute your audio. Raju sir, unmute your audio.
Unmute, sir.
listen to me carefully. While coming to the next class, please read and come from the page number 10 to 10, 11. Yes, only 10 and 11. Only these two pages. 10
Sir, we
and
do not
11.
have textbooks, sir.
No, I have already sent you the PDF. Today, again, I'll send you the PDF of this chapter. You can just go through this.
Okay, sir. Thank you, sir.
Today evening, even I'll give you. Okay, very good. Today evening, I'll give you the worksheets, worksheet question also, which are very important in the examination point of view. Please solve those problems to be given in the worksheets. Okay.
Okay, sir. Thank you.
Sir, side please, sir.
Wait. If you have any doubt regarding today's concept, you can ask me. And again, I have been reminding you, without fail, you have to practice today's one of the two important one. One is regarding the cube of any positive integer is of the form 9m plus 1, 9m plus 8. And another one is regarding an idler and trader problem. This is very important. Third one is finding the prime factorization of the numbers by factor tree method, particularly big number. And fourth one is by using the uniqueness of fundamental theorem of arithmetic, we checked whether the given number ends with 0. These are the 4 important concepts that we have discussed in today's class. Work out all these. Among these 4, 100% one will be given in the examination. Cube of any positive integer, idler problem, then uniqueness and also prime factorization. These 4. Got it? Just ask me if you have any doubt within 1 minute, or else we'll go for concluding the class. And again, I have been reminding you, dear students, please don't keep anything pending on preparation. Please work out the concepts on the same day itself, whatever we teach on that particular day. Without fail, you must
Sir,
work.
side please, sir.
And even we will also go for solving the problems by taking from different reference books, S. Chand, Adi Sharma, and Oswald, as well as from your previous year question papers. And I can confidently tell you that only my notes, whatever I have been giving, is enough for the examination point. You no need to go for touching any other notebooks or reference books except NCERT. NCERT, my notes. These 2 are more than enough in the examination point of view. Okay. Please work out today's concept. With this, let me go for concluding the class. Thank you very much.
Thank you, sir.
sir.
Bye, sir.